Hello guys and welcome to the video number 3 in physics. In this video, we will talk about displacement and resultant. In the beginning, we will talk about displacement and what does it mean in physics. So, a change in position is called a displacement. Displacement is a vector. It's drawn with its tail at the earlier position and its tip at the later position. What does that mean? That means when we want to draw the movement from the origin to the 5 meters here. So we will draw an arrow. The tail of the arrow should represent the earlier position, and the arrow's head should be at the later position. Another example, if we want to draw the movement from the origin to 25 meters, so we should draw the arrow, the tail of the arrow at the origin, and the arrow's head is the later position, which is here. Displacement can be represented mathematically as delta x equal to x final minus x initial. This is the equation for displacement. Delta x equal to x final minus x initial, which is the first displacement. A vector that represented the sum of two other vectors is called a resultant. And this is the definition for resultant. A vector that represents the sum of two other vectors is called a resultant. What does that mean? We have some examples about the resultant. If you can see here, we have the first arrow, which is 5 kilometers to the east. And here we have another arrow, which is 2 kilometers east also. So what is the resultant of these two vectors? The symbol of the resultant, which is r, so the law will be r equal to a plus b. The a here, the sign of a is positive. Why the sign of a is positive? Because the movement is to the right. And here also we have the symbol of b, or the sign of b is positive also, because the movement is also to the right or to the east. So 5 kilometer plus 2 kilometer, that's equal to 6 kilometer. And we can draw the arrow of resultant from the origin until here, which is 7 kilometer east. Another example of vector subtraction. We have here the first arrow, which is 4 kilometer east. And we have another one, which is 6 kilometer west. If we need to calculate the resultant, so the resultant are equal to a minus b. Here we have a different law. Why here we have minus? In the beginning, r equal to a positive. The a positive because the arrow is to the right or to east. So a, we wrote it as positive. And here we have the subtraction, or the negative sign, because that we have the movement to the left or to the west. So the sign of b is negative. So 4 kilometer minus 6 kilometer, the result will be minus 2 kilometer. Or we can find the resultant in this way. R equal to a minus b. Our law was a plus minus b. And the result will be, also here we have 4 kilometer and here we have minus 6. So the result will be 2 kilometer to west. If you write the result 2 kilometer to west, it's the same for the result here, which is 2 kilometer. This is the magnitude of the resultant. So if we need to draw the resultant should be an arrow from the origin to the left because we have here minus kilometer, minus 2 kilometer, or here we have 2 kilometer to west, so we should draw an arrow from the origin to the west just 2 kilometers. We have another example about the vector subtraction. The first arrow that we have here, which is 7 kilometer east, and we have another arrow which is 4 kilometer west. What is the resultant? The resultant are equal to positive A. We have here the positive A as we said because the movement is to the right or to east. And we have minus B because the movement is to the left or to the west direction. So 7 kilometer minus 4 kilometer, that's equal to 3 kilometer. We can find the result in this way also. So R equal to A minus B and equal to A, we have our law which is plus, we can write it as a plus minus B. So here we have a 7 minus 4, that's equal to 3 kilometer to east. This is the magnitude of resultant. If you, as we said, if you find the result in this way, it's the same to this way. So because of the positive sign here, 3 kilometer, we can draw the arrow of the resultant from the origin 3 kilometer to east. So it's from the origin to the east just 3 kilometer as this arrow. Until here, we reached to the end of the lesson 2 in your books. So we have some questions. I want you to answer it and after that send it to me. The first question that we have, which is, which quantity is a vector? Which one of these quantities is a vector? Temperature, time, position, or distance? The second question, what does a vector have that a scalar doesn't have? What does a vector have that a scalar doesn't have? Direction, a delta, quantity, or a magnitude? Which one is the correct one? The third question is, what is the point at which the value of each variable being studied is zero? Which one, which one of these words is the definition of this? The point at which the value of each variable being studied is zero. Is this the origin definition of the coordinate system definition, or the position, or the interval? Number 4, we have, what does the Greek letter delta indicate? A, change in direction, B, change in quantity, C, zero value, D, maximum value. And the last question, what is displacement? Which one is the correct one? It's the change in time and scalar. This is A. B, it is the change in time and vector. C, it is the change in position and a scalar. D, it is the change in position and a vector. Which one is the correct one? So this question for you, please solve it and send it to me. Until here we reach to the end of our lecture. See you soon, inshallah.